Okay, so now that we've talked some about Big O, we have a bunch of projects to do for this unit, a lot of code to go through, and they give you some good starting points. That shouldn't be a huge problem. You are going to need a little bit of time. I thought I would go through and point out a few glitches and also mostly just get you to think about some things that normally we just don't have the time to think about. So I'm going to start with some code they give you in one of the questions, a quick sort routine that we'll be reusing a bit. And they say to put the code in, which is true, but they don't give you this import statement in the code, but you'll need that. So you'll get an error, and when you get an error, then you can add this import so that their code that we give you actually works. Okay, so what else do I want to tell you about? Let's think about this. Here we've sorted an array, right? And here we print it out, but you'll notice I don't just print out the array. You might think, if you're used to Java, you might think that you could, if you were going to print an integer, for example, you would just print something like this, right? System out, println, println, and the name of our array is student IDs, student IDs. So what happens if I do that? What would happen if I were to do that? It cannot be resolved to a variable. What did I do? What did I do wrong? I misspelled it. Helps to spell things correctly. All right, let's see if we can get that. That's better. And I'm going to comment this out for the moment. So I'm going to run this, and it's going to take our list of student IDs up here. It's going to sort them low to high, and then we're going to print them the way you might, if you're just used to Java in general, print them. And of course, some of you are going, but that won't work right, and that's my point. Let's just look at it real quick. So here's our list of unsorted IDs, and that works because let me get rid of, well, let me just take this one out and do it again to make it more obvious. So rather than sort them before they print, I'm going to sort them after they print, but I'm just going to print student ID. And you can see what we get is this sort of odd looking thing. And what this odd looking thing is a class and a memory location. That's what you get. That's the default print statement for an array in Java. It's kind of pathetic. And so what we're going to do to fix that, the quick, easy way to fix that is to take advantage of this method on the class arrays. This is a static method, and so we pass in student IDs. Now notice that saying student IDs.toString will not work. Okay, that'll give us an error. No, that'll probably give us just what we had. That'd be an interesting thing to try. Anyway, it won't work. And so when we do this, we get the kind of results we expect where we see the contents of the array. Okay, so this is something to remember with Java, is that you can't just print arrays. If you want to print an array, this is a fairly clever trick I hadn't thought of. You can call this arrays method toString. That gives you back a nice formatted string, and then you drop the string into a println, because of course println knows how to print a string. Okay. Or you could write a loop, of course. You can write your own loop going through the array and print each item in the array however you'd like. Doing it this way, you're kind of stuck with the formatting that toString comes up with. If you do your own loop, you can format it any which way you want. Okay, so that's first point. Binary search. Binary search example. They give you a binary search example. Let me go ahead and run this, make a couple of points about this code. Some of these may be obvious to you. I'm sorry if I'm too obvious. Enter a number of elements, so we'll say 5. Now, here's the thing. You've got to put the numbers in an order or it's not going to work, okay? Because this binary search assumes things are in order, and it's not sorting them. They could drop one of their sort methods in here, but they don't. I'm just going up by 5 to give myself 5. And now this is the value we want to find. And you'll notice I did 5, 10, 15, 20, 25. So if I look for a number that's not in there, it'll say that the number is not in there. This is very good. All right. Now, of course, that's a fairly obvious case, but I think it's easy to overlook when we write our own routines. We often don't think about, well, what if it fails? Yes, I read a search that's a lovely search if I find the thing I'm looking for, but if I don't find the thing, I might miss it. And we should make sure that we take that into account too. Okay? Moving right along, I wanted to talk about, this is one that you get to write. They give you the basics of this thing, but then you get to add some code for it. This is works off of their quick sort, and I'm going to use this, and this is kind of true of the other quick sort as well, some of these points, but more of them are here, and so I'm just going to use this as my little example. First off, their sort, we get to, where is it? Here. Okay. You see this a lot running around in sorts in Java. Okay. In fact, they're doing something interesting there. I'm not quite sure what that is. But this piece here, this is swapping two numbers, right? So we realize that this is the case where we swap. And so we're going to take one value and stick it into temp, take the other value, stick it over that place in the array, and take temp and stick it in. It's a little if 3 lines of code. Now here's what I want you to think about for a moment. Why not just write a little function called swap, right? I use it a couple of places. It would seem a likely candidate. You could do that. You got to be a little bit careful though, because what you have to do with that is you have to pass the array in and the locations in the array that you want to swap. If you just pass the two numbers in, it's not going to work, and that's because Java uses something called by value, and I don't know if they've discussed this or not, but call by value, when we call a function, we actually make a copy of the thing. So if I say swap A and B, I'm going to make a copy of A and a copy of B, and my function will get the copies, and that means if I swap my copies when I return from the function, it's not going to work. Okay, their numbers are going to be the same, and that's the side effect of call by value. Interestingly, if I pass the array in, it sort of works. It works well enough that you can think it works. We still actually do by value, but the value being passed in when we pass an array into a function is the address of where the function is. So we can't switch arrays in our function. That won't work. But we can change the contents of the array, and that will work. It's something to keep in mind with this. Now, they give you a quick sort that sorts in ascending order, and one of the things you have to do here in this problem is to change it to sort in descending order. And if you compare the ascending order and the descending order, they're not terribly different, very frankly. Let's see if I can find the exact line of code that changes. I think it's there. Let's see. I think it's this line of code. I is less than equal to j. Let's come up here. I less than. That's not what's doing it. This could be embarrassing. I'm not going to find it. But my point is, I'm half tempted to run this and see it actually sorts them. Be embarrassing if this just didn't work at all. Let's see what we get here real quick. No, it works. The ascending goes up. The descending comes down. Let me find this. I wrote this code. I know what it does, right? I did. I wrote it a few days ago. Let's see. It'd be nice to see it over the middle. Let's see. So what's going on here? Oh, here we go. I'm comparing this value to pivot and deciding which side pivot goes on. So it's less than and then greater than. And down here in the descending, it's greater than, then less than. Okay, so here we go. So basically, I'm swapping this and this. Okay, it's not a law code. Now you'll notice the actual routine is fairly long. Let's see, line 65 through what, line 93. A bunch of lines there, most of which are exactly the same. They're only changing in one spot. And so why do we need to duplicate all this code to get here? You might want to think about that. And it turns out really the reason comes down to getting this little thing in. When we're comparing, do we need a greater than or less than? And one way around this that some languages use, there's a group of languages called functional languages, and their ideas are starting to influence a lot of other languages. You're starting to see some influence even in Java, which is a very non-functional language, that basically lets you pass functions around. And so what a functional language person would say, well, you should just have one sort array method, and then you should pass in a function that determines whether it's ascending or descending. It's really difficult to do that in Java, so I don't expect you to do that. But I just wanted you to think about that. You know, we've got all this code, and why is that? It's a good thing to reflect on these things from time to time. And there are languages that let you do that. They let you pass in your comparison method, and then you could just have the code once and pass a little very short comparison method in and change that. Let's see, what else do I want to mention? Oh yeah, when you change your quicksort from ascending to descending, there's actually one other little thing that changes you have to remember, and that's to reset the high and low value. So basically this quicksort is breaking the array into two pieces based on a partition value. All the numbers below the partition go on one side and all the numbers above go onto another side. And you've got to change that too. You'll notice here we have array. When this is a recursive function, right? We call ourselves recursively, and we do low there and high there. Down here we do, see, we swap where low and high is, I believe, don't we? Or am I wrong? Let's see, low is less than j, it's less than j, high is higher than I, high is higher than I. Array low j, array low j, array I high. No, I'm not seeing it. Okay, well, forgive me. I thought you needed to make another change there, and you don't. Never mind. So other things to think about. There's another little program that you do called Machine Shop, and it has you enter a couple of part numbers, and it determines whether the part's in stock or not, right? We do a sequential search on two parts. This is a little odd, frankly. Why are we searching for exactly two parts and not one part or many parts? And I would just suggest, it sure seemed to me to be obvious that you should put this little bit of the thing into a loop and let the person enter over and over as many different parts as they wanted, right? I had a bit of a time figuring out just where they wanted me to print stuff and where they wanted me to return stuff. So if you're having trouble with that, you're not the only ones. Okay, there's some if statements in here. Okay, here's an example. We got an if statement, and this is fine. You'll notice they're not braces here. There could be braces. That wouldn't hurt anything. Since we only have one line in the if, we don't need them. But you might think about, when do you use braces and when do you not use braces with if statements? Personally, I almost always use braces because I find when I omit them, I have some reason to go back later and add a line of code. Often I need to do a print, and I need to see if I'm coming into the if statement, so I throw a print statement in there, and then I need the braces, but I didn't put them in. That's always frustrating to me. Oh, one other thing. In the instructions, the example output is actually incorrect for the code they give you. It basically, the code they give you has a different number of elements that they're initializing it to than the example he ran for the example output. And so your code, even if you do it correctly, is not going to be quite the same as the example output. I contacted the person responsible for that, told them about it. I don't know that they'll change it or not, but if you think your code's right, just count through. It's telling me it's in slot 5, and the example says it's in slot 6. Go ahead and count through and see where it's supposed to be, and trust yourself on that one. Okay? So that's sort of my advice, some things to think about regards to the programming assignments for Unit 4. It's going to take you a little while. It took me a little while. Everything you need is there somewhere, but you have to spend some time assembling the pieces, and you have to do quite a few pieces. I've got them over here, and you can see you end up with, and some of this includes the code they give you, 1, 2, 4, 5, 6, 7, 8 pieces. I think there are 4 or 5 turn-ins, so it's a bit involved. So good luck with all that, and we'll see you next week.